So let's go ahead and discuss function notation. So until this point, you have seen functions as such. You see it as y equals something. So y equals 4x plus 2 would be an example, or y equals 3x minus 8. Anything that's y equals, that's what you're used to seeing as a function. So how can you distinguish between these two functions? Since both functions begin with y equals, we use function notation as a method of differentiating one function from another. The most popular function notation, starting from here, is f of x, which is read as, again in quotes, f of x. This is not f times x, although f of x is most commonly used. Any letter could be used. For example, you could have g of x, h of x, p of t, c of n, etc. It's nothing that's too complicated, okay? So if we're looking at y equals 4x plus 2, it could also be written as f of x equals 4x plus 2. These both mean the same thing. F of x and y, again, mean the same thing. So as you see in the next paragraph, instead of writing the two functions as y equals 4x plus 2 and y equals 3x minus 8, you can write them as f of x equals 4x plus 2 or g of x equals 3x minus 8. And again, there's no rhyme or reason to what letter of the alphabet you choose. It could be anything. The F and the G don't really mean anything. F is just the most common one we use. So essentially, y is the same thing as f of x. And again, you will begin to see them used interchangeably throughout your study of math. So given the function f of x equals 3x minus 6, evaluate the following. Anytime we have f of a number, so for example, f of 2, all we're doing is plugging 2 in for x. So f of 2 would be 3 times 2 minus 6. 6 minus 6, that means f of 2 equals 0. So all that means is when we plug 2 in, what do we get? Let's do negative 7. F of negative 7 would equal 3 times negative 7 minus 6. And again, we would get this, and then f of negative 7 equals negative 27. So once again, all this means is what do we get when we plug that number in. Lastly, we have f of 16, which gives us 3 times 16 minus 6. If we do 3 times 16, we get 48 minus 6, which gives us 42. So now for exercise 2, we're given the function h of t equals 16t plus 40. Evaluate the following. So same thing. It's just an h this time. H of negative 2. We plug negative 2 in wherever we see that t. So we have 16 times negative 2, which is negative 32, plus 40, h of negative 2 equals 8. Now h of 0. That would be 16 times 0 plus 40. We then get 0 plus 40. We get h of 0 equals 40. And now lastly, this one's a bit different. We have h of t equals 88. When the number isn't on the inside of the parentheses like this, we would normally see h of 88 like we've been seeing, and then we think, okay, let's plug in 88. No, it's different this time. We have the 88 on the other side of the equal sign. So what we do is we do 88 equals the function, 16t plus 40, and then we solve. Subtract 40. So then we get 48 equals 16. And if we do that, divide by 16, we get t is equal to 3. So what that means is h of 3 is equal to 88. So if you plug 3 in, you would get 88. On exercise 3, we're given the two functions g of x and k of x. And then it says evaluate the following. So if we're given a, we want to find the value of k of 4, we would plug into the equation that involves k. So this would be k of 4 is equal to 1/2 times 4 plus 6. K of 4 equals 2 plus 6. And then we know that K of 4 is equal to 8. G of x being 20, again, this is one of those examples where we're not plugging in 20. We're setting it equal to 20. 20 equals the function g of x. Subtract 12. And you should get that negative 4 is equal to x. And then our last, we have k of x is equal to 5. So that means here we are plugging in where we see k of x. So we're setting it equal to 5. 5 equals 1/2 x plus 6. Subtract 6, subtract 6. Negative 1 equals 1/2 times x. And we get that x is equal to negative 2. So for exercise 4, we're first asked with a question from the last lesson. Is this graph of p of x a function? So this graph here is some function put on the coordinate plane. So how would we test if it's a function or not? Right away, we can conduct the vertical line test. The vertical line test shows us that yes, this is a function. Yes, this is a function. And that's because it passes the vertical line test. So now we have some questions about some values. So this says evaluate p of 4. So basically this means what is the y value if we look at 4? So let's go to 4 on our graph. Here's 4. It hits the graph at 0. Sorry about that. This coordinate is 4, 0 here. So p of 4 would be equal to 0. Now we have it the other way around. So we're looking for p of x when it's equal to 4. So basically, what is the x value when the y value is 4? So here's when my y value is 4. At this spot right here. So what was my x value that got me there? That would be p of 2. So if you look where 2 is, you follow it up, that gives me my value of 4. So p of 2 is equal to 4. On exercise 5, we have something very similar, okay? So we're looking to evaluate parts of this function. So it says evaluate h of 2. H of 2, again, this is asking us, what is my y value when x is 2? Because, again, this line on this coordinate plane is some function at h. So here's 2. We follow it up to the graph and see where it hits. It hits at the value of 4. So h of 2 is equal to 4. B, we're looking for the value of h of 3.65. So basically, what is the value of y when this is 3.65? So 3.65 is somewhere between 3 and 4. We follow it up to the graph, and where does it hit it? Again, at 4. So h of 3.65 is 4. And then lastly, we want h of t equaling 2. So now we have to do this function in reverse. So basically they're asking what is the x value when the y is equal to 2. So let's find out where y is 2. At this point on the graph, what's the x value? 1. So that means h of 1 is equal to 2.